Hello. So this video again is sponsored by Autodesk, and what I'm going to do first of all is I've made a cylinder here and I'm going to duplicate it. Control D. Yeah, okay. And on this one I'm going to add some bones and just bend it. So ding 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 ding. Not called bones, are they? Joints. That's what I meant. And so I'll skin it, and I will just bend it like that. Yeah, that'll do. Anyway, this is just to demonstrate a thing that I do sometimes in ice, which is using a reference mesh, this one, doing some deformation on this, which is static, and this one here will be animated, and I actually want the effect on here, but because this is bending around and doing all sorts of stuff, it's easier for me to use this as a deformation reference mesh, and it'll become more apparent when I do it. But basically, yeah, well, yeah, I'll just do it because it'll make more sense when you actually see it. So I've got this this thing here which I'm going to use as a bulge. In fact, let me call this bulge. I'll call this one reference mesh, and I'll call that one target. I don't know. It's not target anyway. It doesn't matter. What they call doesn't really make a lot of difference, to be honest. So I'll create a graph. I'll bring all that stuff in. Don't need that input. So bring in ref, target, bulge, and first of all I'll just use these two. So ref shape is this one, and this is what I want to first of all do a bulge on. So I get point position, and I'll do some stuff to it, and then I'll set point position, and I'll hook that up so that we get a biff, and I'll move the biff out here. Okay, so then we'll do some stuff to this. Just make it so we can sort of see that as we're going, but I need this pretty big. So what I'm going to do is I'm going to raycast out from these points and hit this here, and then use that amount to bulge it. So raycast, get raycast locations is what we need first of all. Now raycast, I think I might have showed it in another video. It's sort of like, it does the same thing as get closest locations. We need to tell it what geometry we want to raycast onto, which is this bulge shape, where we're raycasting from, which is from these positions, all the point positions on the object. We also need to give it directions to raycast in, because it basically fires out like a line from each point. So we're going to get point normal, which is the most obvious thing to use for that, and that's going to give us a bunch of locations on the surface of this. And what we want to find at each location is just its position. So we need to sample property, get those locations. We want a sample property on this bulge shape. The default we want to find is just a vector, like a X, Y, Z, which is just like a position. And if we plug that straight into the position of this, then what we'd get on the biff, this one here, is where it's hit the ball. So, right. And what it does, strangely enough, which is sort of different to ice, is where it hasn't hit, it just doesn't return any value. So they've all just sort of defaulted back to the origin. So that's no good. What we want to do instead is say, if it doesn't hit them, then just use the original position, which is back here. This is the gate point position. And luckily this thing gives us a little Boolean output thing, like a yes or no, whether it hit or not, and it's called success. So if we plug that into an if node, we'll say if it did hit, then if it's true, then we'll get these positions here. If it didn't, we'll use the original point positions. And now if we plug it in, we get the whole thing. So if I move this ball around, you can see that it's updating. Now the normals aren't updating properly, so we have to do that thing at the end where we update mesh normals. So it's called update mesh normals. We just plug that in at the end and it should draw it properly now. I mean, it's not exactly the same. It does this weird little interpolated thing at the top and bottom, but anyway, it looks better than it did. So we can move that around and it will kind of bulge like that. But we want to get that effect on this one, not on, you know, not on the one that's straight. So if we want to get it on this one here, we could do something, we'd have to do something slightly different, because if we just set it on this target shape, say for example, we get this effect happening. Well, actually it won't look any different if I just do that. The reason why that is because we'd need to get the point positions. So if I copy and paste that, if I plugged it, we got the point positions from there and plug that into the, well, that's too complicated. Anyway, what we want to do basically is work out how far each point's been moving and then use that to bulge this one out on the normals. So where these points are not hitting the bulge at all, they're just not doing anything. And where they're hitting the bulge, they'll have gone out a little bit on their point normals, because that's where the direction we're firing out the ray from. So to do that, I'd need to find the length of how far it is that they're traveling before they hit this thing. So we know where they were originally, that's just their original point position. We know their new positions, which is out after the result of this. So what we need to do then is subtract one from the other. So subtract that from that, and that will give us a length. Well, it won't, but it will, we can find the length if we do that. So out of here is a bunch of values which give us the length, how far each one's travelled. And obviously where they've hit this ball, they're going to be travelling out further than just, you know, nothing, which is just, you know, most of those points aren't hitting anything, so they're just going to be exactly where they were at the end of here and where they were originally, because that's going to be the same, they haven't travelled. So these lengths now we can use to plug into a push deformer. Instead of setting this point position like that, we can just get the original point position here and push them out on the normals. So if we add the point position to its original normal. Now if I do that at the moment, they'll all uniformly push outwards, if you just see, like bonk, like that. But we know that where it hasn't hit, we want them at 0, and where it has hit, we need to basically multiply it by this length. So it's going to be, the normals are, where it's 0, they're not going to be any value at all, and where they've hit this, they will push out by that amount. So we need to multiply this input here. So multiply and get that normal thing, go into the multiply, then go in there, and we need to multiply it by this amount, this length. And now you see it's doing effectively the same thing, but we're doing it in a slightly different way. We're not taking the explicit positions, we are doing it like that. So it's finding how far it's travelled, each vector has travelled to hit this ball, and then we're just saying, okay, move that amount on the normal. And now we have something which, because we aren't taking the explicit position, we're just pushing out on the normal, and this one is topologically the same, this target shape, we can apply it to this instead. So we can hook it up so that instead of using this point position, I can copy that, paste it, I can plug that one in, and I can add this amount on the normal to, well, I'll get point normals and do it for this one. And now we can use, we can hook it up to this one. So we use this one's point normals here and add it to this one's position. And you can see there that it's doing it to this. So this is just quite a cool thing, because it means that, you know, if you were doing I don't know, a scene where you've got, like, you wanted to have, I don't know, like something in The Mummy where there's like insects underneath the skin or something like this, you can animate them around on a character that's just static where you want them to go, but they will, you know, but then you've got your actual character animated like this with bones, because this can be moved around, you know, it's not you know, this can be animated however you like in the scene, and you could use, you know, these little bug things to animate on your reference, and yet it appears on your animated mesh. And if you wanted more of these balls, you could duplicate that, and I'll show you something else you can do here. So okay, so we've got 2 balls now, so I'll bring in that bulge. So we've got the original bulge shape. Let's bring in bulge 1 shape, and we can merge these two together with a merge node, merge geometry. Now this only takes, this took me a little while to figure out, this only takes 1 input. Basically you have to make an array out of these. So you do build array, because you're going to make arrays out of bits of geometry, so that's like an array of geometry, so we like a list of geometry. We've got that one and we've got that one. If we take that into the merge geometry, what's coming out of here is the 2 meshes as if they're one bit of geometry. So we'll hook that up to this tree instead, like that. And yeah, so now we've got 2 balls effectively that we can animate. You know, and this can be, you can have as many as you like, you know, it's yeah. So I thought that's kind of like a quite a cool effect that I use for, in my character work, I use a sort of variation of this type of thing. But anyway, I mean, I know that's ended up like a complicated tree. I feel like I should say again, for those of you who look at this and go, well, that's a really complicated workflow, you wouldn't make this every time. You'd have this as a tool which you can just plug this stuff into. So, you know, you'd have these 4 things here as inputs. You might expose some parameters of, you know, whatever. But effectively, this thing here would be, I mean, I'm just doing this just off the top of my head, but you would basically do that, and you'd do Control G. That would make it a compound, and, you know, next time you use it, you just have to plug these things in, basically. So, you know, you'd call this bulge reference, or, well, I don't know, whatever you call it, you know. So now these things here have come out in a weird order, and I don't know quite exactly how it's chosen to put that there, but if I wanted to move this one to the bottom, I can go on there and I can go move port to bottom. Then it's a little bit more obvious, and that, again, you know, you can, whoops, you can rename all of these. So you could say this is the reference. Whoops, I keep doing ice-like things. You know, this one, bulge, that one bulge. Actually, that was in a better position, so I could move that back up. I'll move that. That was in a decent position. So you'd call that target. Yeah, target. You know, that bulge and that bulge as well. You know, and next time you just have to bring this up. You know, so again, it's tempting to sort of like look at my workflow and go, well, I don't want to do that every time. The point is, if you do this a lot, you don't do it every time. You just bring this up. You just bring that into the tree. That's a compound that you can just bring in, and you know, what you do after that is you go publish, bulge ref, publish. Now that's it. So say you're starting in the scene, you go, okay, hit tab, bulge a ref, that's just there. You go, that's my ref, that's my target, that's my bulge, that's my other bulge, and pop, that's it. That's how long it takes to set it up, not what I just did inside here. This is the building of the tool. I just want to make that super clear, because I know people think, who people are new to this get confused between the application of the tool and the making of the tool, which is a natural thing to do. I mean, often when you're working with this and you know what you're doing, you probably, you would probably do some of this, because you might think, okay, well, I need a slightly different effect to happen. So you would be doing some of this editing, and it is important, obviously, if you're building your own tools, to know how this is done. But there's many levels of, some people will never want to go past this stage, and that's fine. But for those that do, that's kind of why I'm showing these tutorials. Anyway, I'm waffling, so thanks for watching, and I'll do another one soon. Cheers, bye bye.